So today and tomorrow and the next day and the next day and the next day, we're going to be talking about two things. One of them is exponents, and the other one is what we call radicals. So I don't think that radicals are even going to come up today, but just for the record, radicals are these things. You know this one is a square root. If I add a number here, this is now called a cube root. If I change that number, it's now called a fourth root, so on and so forth. So we will eventually get to the relationship between exponents and radicals, but today's lesson is just all about exponents. And the good news is I think that Mr. Manlove last year, probably in eighth grade, did this. This is where we get a little bit, this happens a lot in eighth grade math and algebra one, where we get some crossover, like overlap. So don't be surprised if you find yourself like rock starring the notes, like your voices are, I'd love to hear them, like as you flex on me and show me that, like, hey, I already know this property. So again, I'm going to try to do about 6 or 7 minutes of notes, and then we'll open our Chromebooks and do a couple problems, and then I'll do another 6 or 7, and we'll just kind of repeat this process during the hour today. Yes, Tyler? Uh, can we wait on that? This isn't a good time. We're going to take notes right now. So, um, good to go? Right. So the first part of this lesson is going to be the clunky part, and there are 7 properties of exponents that, oh, no, excuse me, yeah, 7 that I've got to throw out there to you. So don't get overwhelmed by this part. I do think, again, that the good news is that you've seen these properties before. And I don't know how Mr. Manlove across the hall would have taught this, but a pretty conventional way to start is to say this. Get used to seeing lots of letters in today's notes, and don't be intimidated by them. What's going to happen is every time I give you a property, I'll give it to you in what's called its general form, and then I'll show you it in its practical form, like just in use, like in the wild. So does anyone know what happens if you take x to some power and you multiply it by some other x, but to a different power? Do you know what you do? Good try. But no, that one will come in. That'll be an answer later on. Perhaps to enable you to answer this question, let me put a math problem up here. Because it's always the best way to learn math is to take things that look confusing and make them not so confusing. What if I gave you x to the fourth and I asked you to multiply it by x to the third? Do you guys know what the answer is? Yeah, I mean, your answer's one of two things right now. And the right one is to say x to the seventh. And the property then, I know it's like, dang it, I said 12. And a normal person would say 12, like, because 4 times 3 is 12. But I can sales pitch you on this really quick because x to the fourth looks like this. You would agree, right? And x to the third looks like this. You would agree. And you can't deny me then that if I multiply those two packages together, it just becomes a counting game, right? How many X's do you see? 7. So because of that, we can now maybe complete the property using letters instead of numbers. What is x to the power of a times x to the power of b?
See,
It's x to the something. What did we do with 4 and 3 to get? I'm so sorry that I just wrote 7. I, of course, meant to write x to the 7. That's what it is. Good job. It's x to the power of a plus b. And again, I have to do this, but I also want you to know as we go that, knowing how to use it in the wild is more important than being able to recite it. Like, I'm not going to give you a test on, recite the 7 properties of exponents. I just want to know if I put a math problem in front of you, you know when to add the exponents together. And that is when you do. And I'm gonna kind of go out of order in my notes here. I'm calling an audible on myself, but I want to show you the one that you guys get this one confused with. You guys being like people learning math. So that's the first property, 1 down, 6 to go. If you have x to some power and you multiply it by another x with another power, you get another x, but the power is the old powers added together. Yeah, Jojo? I did? Oh, I didn't even mean to. Rad. Here's the next property. X to the power of A raised to the power of B. What do you think this one is?
The power AB.
That is correct. And my heart goes out to you as you try to learn the properties because it's really easy to get them confused. Um, if you're a conscientious student, you you'll never miss these if you care. And I say that because like if I get stuck, if I'm taking a test and I forget which is which, there's nothing stopping me from making it up on my own. Like it's called I can put it right on a plate in front of me. And what I mean by that is like for this second property, I could just make something up. I like to put numbers in place of A and B. If I were a kid, this is what would make sense to me. I'm going to take like x to the third and I'm going to raise it to the fourth. The answer to this can be found when you forget, not if, but when you forget, the answer can be found by doing what this quite literally says. It says to take the thing in parentheses and multiply it by itself 4 times. So I can actually illustrate this for when I forget. So here comes x to the third once. So you ready? X to the third once. Here comes x to the third again, twice. Here comes x to the third thrice. And here comes x to the third 4 times. If you understand exponents even at a very baseline level, you understand that the what I have written on the left and what I have written on the right are the same, correct? Well, now I can just use the property from before and I can just count them up. I can go 3 plus 3 plus 3 plus 3 is x to the 12th power. And if that's not enough of a sales pitch for you, you could even go next level and break every one of these x to the thirds down into xxx, 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 XXX. And I mean, there's zero chance that you couldn't convince someone that that's 12X is sitting in front of you, right? So those are going to be the two that you're probably going to hate the most because we always forget, we, again, as humans, we forget when do I add the exponents and when do I multiply? So if they're side by side, like the first one, we add. If it's just 1x with a power raised to a power, that's when we multiply. Got it? Okay. The next property is this one. X to the power of A over X to the power of B. Got it? Write that down. Hello? No, I don't. Did I not marker? Sorry. Yeah, thank you. Okay, bye. Slacker. Slacker. What do you guys think the answer to this one is? And if you don't know, again, what I'll do with you is just the same activity as I did before. I'll allow you to discover the property by just making an example. You think you know? It is not. Melissa? That's what it is. And I'm sorry, it's a fact. I'll say it again. My heart goes out to you. Learning algebra is hard, especially on days like today when your math teacher chucks 7 things at you. But if I'm sitting here and I'm doing a test or a worksheet or something, and I'm like, I don't remember what to do, I empower myself by going off to the side and making an example. And I say, okay, if I have x to the sixth on top and x to the second on bottom, this fits the mold, right? There's nothing stopping me from saying that on my top, I have 1, 2, 3, 4, 5, 6 of those. And on my bottom, I have 2 of those. And you learned way back in 4th grade, probably, I'm guessing, how to reduce fractions. And you see that this x that I just crossed out can cancel with this x, and that this x can cancel with this x. What do you see? 4. I see 4 of them, and you do too. And that's why the answer is 6 minus 2. X to the fourth. Yeah, Jojo.
Oh, so you did that on
Do what?
like maintenance.
Of course not. I would never mind you doing anything that makes you a better mathematician. I think I will say this, you won't have to probably because you're going to do enough of this in the next week that you'll just know it. But if you brain fart it and forget, yeah, that's what a powerful mathematician should always do is go off to the side and try to make an example that brings them back to brings you back to the light, so to speak, right? course I would. I'd be thrilled. Yeah. Then, so we got three down. The next one is it's going to feel to you, you're going to want to call it like the distributive property. And it's not what it's called, but who cares what it's called? It's this one. This is the fourth property. Yes. Again, and this one's harder to justify, but it can be done. This one's better to memorize. Any thoughts on what this would be? It's already the quantity of xy being raised to the eighth power. What do you think that breaks into, Jojo?
Plus five.
Oh,
They're both raising
so what do you think it equals?
like, where do you think, where I think the answer is?
Mhm.
Um. X raised to a power plus y. No, is it multiplied? Okay, so it's X raised to a multiplied by y raised to a.
There it is. That took a little while to get there, but you got there. It's always worth the journey, you know. This one feels like distribution, and as far as a casual guy like myself is concerned, call it distribution. I don't care. It's technically called, if you want the fancy name, the rule of a product raised to a power. I don't care what it's called. At the end of the day, what it boils down to is it does feel exactly like it works. You feel like you see parentheses, you want to get rid of them, and you can do this. You can take this exponent and you can actually distribute it to everybody inside. And that property can be expanded, by the way. Like if I had a triple inside, if I had like x, y, z to the power of a, I can expand that distribution as much as I need to. It would be x to the eighth, y to the eighth times z to the eighth. Like that distribution can go on is provided that the things inside are connected by times and that there's no plus or minus, because that's a more algebra 2-y kind of thing. If everything inside is just kind of clumped together, distribute to your heart's content. Okay. So an example of that would be something like this. Say you had 4x to the third and you raised it to the second power. This will be your first like legitimate math problem of the day. The rest have been pretty clunky, kind of silly. This is legit. So what we're going to do is we're going to distribute, right? And the reason I say that is because you would agree that there are two guys inside. There's a 4 and an x. So the 2 says, here I come. I'm going to distribute to this clown over here. What does that become?
Or this
4 to the second, also known as 16, right?
16.
And then what is the x going to become? Nope.
Oh, no, to the fifth.
Nope.
Oh, no, it's six.
Yep.
Wow, that's fine.
Don't worry. Yeah, that's tough. That no, that you guys did a great job. That was a big jump from what we had talked about a minute before. That's a leap. But that's kind of what our math problems are going to start to feel like is I don't know if you knew this or not, but we actually combined two properties in one problem. We did the distribution property, but then we also, in this yellow part right here, I didn't even show it. I was testing you guys. We wound up with x to the third raised up to the power of 2. So you got to use a prior property in addition to the initial property, which was pretty cool. That marks the point where I can now say 4 down, 3 to go. These are the hardest three for some reason for young people. They won't always be, but they are right away. So the first one says this, that if you have x and you raise it to a negative power, my Algebra 2 students, we still talk about this well into Algebra 2. It still comes up in pre-calculus. Like this concept never goes away. Um, and I'm going to ask if you know this one. Have you ever seen a negative exponent before? They exist and they're going to exist today.
Oh.
You ready for this? Here's the answer. It's 1 over x to the power of a. I know. Let me summarize it for you. Let me give you the Cliff's Notes version of what just happened. When something has a negative exponent, You grab it in your hand and you throw it into the bottom of a fraction and you're done. Notice as I threw it into the bottom of the fraction, though, I changed one little thing. I changed the exponent from a negative to a positive. So here's an example. Say you had x to the negative fourth. What would the answer be? Build a fraction, fill the top with a placeholder, done. How about this one? Build a fraction. It'd be 1 over 25, correct? Okay. So that's how your first negative exponent property works. He says if something has a negative power, pick it up and move it to the bottom. The next property is directly correlated to the property we just learned, and it says this, that if you have something that is in the bottom of a fraction with a negative exponent, I say these are the hardest two. And I wish this didn't take so long.
Could just be a positive.
What did we do when something had a negative exponent about 1 minute ago? We threw it in the bottom. We threw it in the bottom. What do you think we do if it has a negative exponent, but it's already in the bottom? We throw it up to the top, and the answer goes back to being x to the a. What eventually, when the smoke clears and you see this with confident lenses, you're going to see that negative exponents are really stupid and easy. All they do is move things from the top to the bottom or the bottom to the top. They're just like an elevator, up and down and up and down. So an example of that would be something like, what if I had like 1 over and I had like y to the negative third? What's the answer?
Y to the third.
Done. It just moves up. And when I say up, some people are like, it didn't move up. And I'm like, yeah, huh? It's just in a fraction that we wouldn't see at this point. So that was properties 5 and 6. The negative exponent properties are demons. The last one you'll appreciate because it's simple, pimple. It says that anything raised to the power of 0 equals what? It's not 0. Oh, God, it is actually 1. And if I hadn't already been droning on so long, I would explain to you why that is. But maybe remind me tomorrow and I'll show you why that property works the way it does. But your brain's probably too full right now to appreciate the explanation. So those are the 7 properties. Now we are going to do 4 examples, and we're going to try to do them pretty quick. So here it goes. This would be officially like example number 1. You look at this and you might feel a little bit intimidated, but really it's just using property 1. It's a little bit clouded and gummy and messy, but it is just property 1 buffed. So here's what your teacher is going to tell you to do. Step 1, always go through and multiply all of the stuff that has nothing to do with being in high school. The little kitty stuff. I spy with my little eye a number 15 and a number -4. And just like I've been doing since 7th grade, I'm going to just multiply those guys together. And what is 15 times -4? Perfect. Always do that first. Go through and pick the low-hanging fruit. Get any multiplication problems you can just pluck out, get that garbage done, and now we can get on to the good stuff. So how many x's do I have on the left?
2.
How many x's do I have on the right? How many x's do I have total? Try again. X to the 7th is part of my answer. How many x's or how many y's do I have on the left? How many y's do I have on the right? How many y's do I have total? There you go. Done. Okay.
Not just right.
Believe it or not, yes. Let's go again. Problem example number 2. We're going to do -5 y to the 4th times -3 y to the 8th. What is job 1? Again, please, yes, pick the low-hanging fruit. Just look for the little kitty math. There's a -5 and a -3 that have absolutely nothing to do with high school mathematics. That's just a multiplication problem. What is -5 times -3? So 15 is part of my answer. How many y's do I have? 12. I got 4 in the left being multiplied and powered up by 8 on the right. They come together and say, hey, let's make a pack of homies. And they make a pack of 12. There used to be 4. They got joined by 8 more. There are 12 of them total. Next one. 7 times negative 2x to the 11th, y to the 4th. The reason I wrote these examples is I pulled them right out of your assignment that you're going to be asked to do. So what I tried to do was just keep looking through the problems to try to find a representative sample of what you'll be expected to know. Joe, what do you think it is? You would always do that first. And what is 7 times negative 2? And then what do we do with those x's and y's? You just stick them on there, right? I wanted to make sure you saw this, that you don't always have to combine X's and Y's if there's none that are combinable. Sometimes you just do the little kitty part and then you just slap on letters because that's all that's left, right? And then here's another example. X squared times negative 5, x to the 5th, y to the power of 2. What is this negative 5 thinking right now? What's he doing? He's being a loner. He's looking around this problem and saying, boy, I sure wish there were another boring little kitty number like me that I could multiply with. And he looks around, and the logical place where that number would be is right there. And then he gets there and he's like, well, I guess I'm a loner. And so he will just transfer. You're right, it is just a 1. But he just says, you know what? I'm just going to go into the answer like this. And then we alphabetically, you should always, a good algebra person generally is going to work in alphabetical order. Go find your lowest alphabetized letter, which in this case is X, and do your thing. How many X's will you have? 7 is correct. You're using properties without really talking about them. You just start to understand this is what I do. How many Y's will I have? Nice. Um, I'd like you to get your Chromebooks out. I'm going to pause this real quick because this will take 30 seconds. I want you to get your Chromebooks out. I want you to flip them open and go to Delta Math or Fubble. Have we gotten one right? This whole section of problems, I assigned, I believe, 10 of them, should take you no more than a few minutes. I mean, once you understand kind of the method. It's really simple. You go through and you paste your numbers together first using regular old school math, multiply, multiply. And then you go through and find all your x's, add their exponents together, y's, add their exponents together, z's, if there's any, add them together, whatever there are, just mash it into one little package. Did we all find some little modicum of success there? You okay?
Yeah.
The the first the first thing in the assignment that says multiplying powers. All right, finish whatever problem you're on and get back to your notes. So here we go again. So what you just did, what you just learned was a little bit of a package that's going to help you through those 10 problems. Your next 10 problems are going to look like this. So you see now we've transitioned into another property. So let's, as a class, work to figure out if you're still on your Chromebook, make sure you've quickly finished whatever you're doing. I do not want you doing those problems while I'm trying to get you ready for the next one. So we're using in this one that distribution sort of property, right? So we're going to take the 4. This would be your 5th example officially, by the way. We're going to take this power 4 and we're going to stick it right on that 2. What is that 2 going to become? 2 to the 4th power, which is 16. 2 times 2 times 2 times 2 is 16. Now, I should have used a color for that. I'm gonna switch colors now and be more careful. When this 4, follow the green arrow, goes to the X, what does he become? I wish it were 7. My job would be a lot easier. This is where the rules start getting confused. It's already got a power of 3 and gets raised up another power of 4. It is a when we multiply 12. And then what is the Y going to become? Right. Let's practice that again. Let's do -3 times X to the 10th times Y to the 3rd. And let's raise that whole humdinger up to the power of 2. I'll do better with my colors this time. B plus on that last one, C plus maybe. The 2 is going to head over like this. And what does that become? Nice job. That becomes -3 up to the power of 2, which means we square it, which you guys know from your past experience means it becomes a +9. Nice job, Embry. And then we just keep on keeping on, and I'll do green again for my second one. What's X going to be? X to the 20th and Y to the 6th. You're killing it now. I want to do one more, and I'm going to skip one of them. Yeah,
Why isn't it -9?
because the whole negative is assumed to be getting squared. It's a really good question. And when you square a -3, it becomes a +9. That's a really, really good question. And that we could delve deeper into that explanation, but for now, that'll kind of have to do. Okay. Great question there, Rowdy. Thank you. I wanted to do this problem with you. To the casual observer, they might say, well, this is just like what we just did. It's really not. There's a little bit of a different twist to this. So let's start with the red. What happens when you take -5 and raise it to the power of 3? It becomes negative first off, and I'm proud when you say stuff like that because this number that I'm circling in red is a negative. And when you raise it to an odd power like this, just look at the math. It's a negative times another negative times another negative. And in math, you know what happens for every 2 negatives you do times.
Positive.
They become a positive, but then you've got the straggler negative. So this part is negative. Good job, Embry, but it is -125. Because 5 times 5 is 25, which times 5 is 125 again. And then the rest of it is just, of course, the same old thing. So what would my Y be? What power would I have on? Oh, excuse me, my X. My X would be 12, and what would my Y be? 15. So it's pretty rare that I ask you to do work not with me, but we've been together for 30, this is our 39th time. I've asked you to like literally go home and get something done that night, maybe through 2, 3 times. I'm asking that of you today. What I'm going to do is I'm going to go into that Delta Math. I'm going to edit it by taking out the third section since I ran out of time. I want you guys, when you come back in here tomorrow, to have 20 problems done. The 10 from the first section and the 10 from the second section. Can you handle that? You'll see there will not be a third section because I'm about to delete it. So just finish the Delta Math.